Good evening, guys. Today we will be discussing about XGBoost classification. So, XGBoost is nothing but a updated version of our gradient boosting, and we know that in the boosting technique we train a lot of weak learners in series. So, first of all, I will be telling you about the classification problem. Suppose I have my x independent feature, and on that basis I will be deciding what will be classification. Suppose there are four values x1, x2, x3 and x4, and I have 0, 1, 1, 0. These are my labels, that what will be its classification. So first of all I will be moving towards my base model. That is the first step in the gradient boost also. So, what is the work of our base model? The first it will do is average value of our y labels, that will be 0 plus 1 plus 1 plus 0 divided by 4. 1 plus 1 2 4, that will be 1 by 2, that will be 0.5. So it calculated the average value of our y label. Now what? It will not stop here. We have another concept, that is log of odd, and log of odd means it has a formula of 1 minus p upon p. Here p is nothing but the value which came here, that is the proportion. Okay, so what will be doing? 1 minus 0.5 upon 0.5, that will be 1. Okay, so we get that log of odd value is 1. Now what? Now the value which we get in the log of odd, we substitute this in the sigmoid function to get the final prediction of our base model. What is the sigmoid function? It is 1 plus e raised to power minus z. So in place of z I will substitute it, and suppose I am getting some value y1. Okay, so this is my prediction from my base model, so I will write it here. And we know that the base model prediction is same for all the values, so y1 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 and y1. Now what is the second step? Second step is the calculation of the residual. Okay, we have calculated that what will be the difference between these values. So suppose I am getting some residuals here. Now till here we are clear. Now what we do, we know that in the XGBoost, now we will train a weak learner, that will be a decision tree, whose work will be to update these residual values so that it goes to 0, so that the prediction value and the true value becomes nearly equal. So for that, what will happen? For creating a decision tree, we know that first of all we have to select a threshold value. Threshold value means what? The value in that is taken from the x features on which we will get the best classification, and the possible values on which we can do classification is nothing but the average of the consecutive two values. Suppose here comes x5, x6 and x7. So what I will do, if I will do splits on x5, x6 and x7. Suppose I choose x5, so I do x5, so all the values that will be less than x5 will be coming here, and all the values more than x5 will be coming here. Now what will happen, this is my root node which will consider, which will be having all the predictions residuals, and here the residuals of all the values which are less than x5, here the residuals of all the values which are more than x5. Now what we do is that we calculate the similarity score for this root node, and for this child node also, and this child node also. Now what is the formula of our similarity score is, that is summation of residuals square upon summation of previous probability into 1 minus previous probability. Okay, this is one term, and this plus lambda is in the denominator only, but it is not under the consideration of the summation. Now so lambda is nothing but our regularization parameter. So residuals, you must be, when you will calculate, you will be getting residual value here, and you will be getting residual value here also and here also. And what is here our previous probability? It is the y cap which came after applying the sigmoid function. Okay, so With the help of this formula, you can calculate the similarity score for this one, and this one. Then what we will do, for knowing which is the best split, we are going to calculate our information gain. And for information gain, what we will do, in information gain we do nothing but similarity score of left node plus similarity score of right split node minus the similarity score of our parent or root node. Okay, so we will calculate this value here. Okay, similar process will be followed for x6 and x7 also, and then we will check which one is giving the highest information gain, then that split will be chosen as the best split. So till here you are clear that how we decide that we have to do what split. Now suppose I have chosen that x5 is my best split, and I came here at the left node and the right node. Now it is on me to decide how much depth do I need to go. Suppose I decided I only want to go to one depth, so I will stop here and stop here. Now what I will do, I will calculate the output for the values that will come under this leaf node and that will come under this node. Okay, now I will be telling the formula for the output. The formula for the output will be summation of the residual upon summation of the previous probability into 1 minus the previous probability plus the lambda. The formula is just same, but here is square, here is not square. So you can calculate the output for this output 1, this is the output 2. Okay, you are clear till here. So now what will happen is we have also calculated what our node will give output for values that will come under it. Now the last step will be updation. In the updation, what we will do, we know that m1 plus alpha m2. M1 is what? M1 is our log odd. Log odd means this value which we calculated here. Okay, 1 plus alpha is the learning rate, and m2 will be, suppose our value was something which is less than x5, so it will go under this node, and we found that its output is output 1, so we will multiply this output 1. Then the final value, or I can say I will get a log odd prediction for this value. Similarly for x2, x3 and x4 will be doing this. Okay, so now what will happen, similarly we will get the log odd or the log prediction for these values, and then what we will do, for each value that will be coming out for x1, x2, x3, x4, I will apply the sigmoid function over it, and after applying the sigmoid function I will be getting the prediction from for the model. Okay, so after doing all this I will be getting the new prediction which my model has predicted for all these values. Now the similar step will be taken place, this will be forgotten, again a decision tree will be made, again the decision tree will be made, again the output will be calculated, again this step will take place, again new predictions, and this cycle goes on till the residual or the error comes near to 0.